right, hi everybody.
Hello.
Ahoy! So this is John from Box. He's one of the operations guys at Box, and Box has been rolling out OpenTSDB. When did you guys roll out OpenTSDB?
About 14 months ago.
Okay, so a little more than a year ago. I wrote OpenTSDB. I stumbled upon because I didn't really like any of the time series systems that we had, like Cacti and Mean and such. And so what we're going to do now is give you a short intro on TSDB and then talk a little bit about the use case at Box and tell you more about what Box does with it and what they had before and how they came to use OpenTSDB and why it works for them. All right, so I guess I'll take this one. So the idea behind OpenTSDB is you just want to get a lot of data from your systems and you want to store it forever and be able to access the data later. So you have tons of servers, applications, devices, switches, everything, and they all produce tons of numbers. You have like a lot of metrics in /proc on Linux, for instance. You have a lot of SNMP data coming from your switches. You have your applications expose a lot of metrics about the number of requests they serve, their latency and everything. So you want to get all of this data and like store it forever. And OpenTSDB is a distributed storage system that makes it really cheap to store lots and lots and lots of time series data and get it back. So yeah, it's written on top of HBase. HBase is a distributed NoSQL data store modeled after a big table at Google. And it scales really well, so you can add tons of servers and it will help you scale your storage system.
Okay, so we have a couple of assumptions that you have lots of servers and devices, and we'll let you define lots. And you want to know what they're doing. So before we had OpenTSDB, we used a couple of different monitoring systems, ranging from a lot of Cacti and a Luna on each host to a lot of that duct tape stuff the previous guys were talking about. We had a lot of that.
I think that sounds very familiar to a lot of people in this room.
Yeah, so our developers as a whole, like anybody outside of ops, had no idea what was happening in production. They really didn't know what happened to a piece of code once they put it out there. And you know, for example, we use Nagios for monitoring. We really didn't know, like, you know, how is this service doing as a whole across the data center, across the system. You know, we could monitor each host, but a lot of times we didn't want to get 500 pages because all the servers of one type are having an issue. We just kind of wanted to know that that service in this facility wasn't available anymore. And we definitely didn't care if just 2 of them were broken. So and this is a lot of the Cacti stuff, but the way the polling was worked, you know, to get new metrics in, we had to dig through that Cacti interface. We had to add some templates, and you know, even though we used Cacti a lot, we kind of got familiar with it. It still felt like it was kind of black magic. Like you never really felt like you understood what you were doing. The polling wasn't scaling. It wasn't very easy just to add more machines and now we do more checks. Distributing those checks and figuring out who does what check, it really wasn't very good. So whenever that would fall behind or get too busy, we just lost the data. So a lot of our graphs would look really good, but then there'd be this weird gap for an hour and 10 minutes, and then, you know, lots more data. So we had no idea what happened at that time. The times where it tended to break were the times where something else was broken. The times we needed it the most was when there was holes in the graphs. And so kind of we battled that by dropping less important data and to try to keep the really important ones working. So, you know, we didn't keep up with individual servers' network interfaces anymore. We just graphed like aggregate interfaces on switches to the core routers and, you know, out to the internet, that type of thing. So we lost a lot of visibility just to keep the polling working.
I think this is actually a very common problem of a lot of monitoring systems is you have this one big thing in the middle that has to keep track of everybody else, has to keep track of all the targets, all the applications, and all the devices and servers you have, and it can't keep up. And when you know that you're outgrowing what you can support from this central polling place, you're kind of screwed, right? Because you need to sort of shard your configuration, you need to sort of split your config in 2 halves, and then say, okay, now I'm going to have 2 monitoring nodes, and one node is going to poll half of the world, and the other node is going to poll the other half of the world. And every time you outgrow your current setup, you need to go through this painful resharding process. And also a lot of the systems, they're not really built such that when you have multiple polling points, you want to still be able to view all your data as if it was all in the same place. And so a lot of the systems suffer from this issue, and ironically, even though OpenTSDB borrowed on a lot of concepts and ideas that were made up the monitoring system at Google, Google also had this very nasty problem that they had specific nodes and applications running in some places that were polling everything, and all of those issues were also true at Google. And so the way I built OpenTSDB was specifically to avoid running into this problem again, because it's such a common problem and so painful.
So a lot of systems share the common background of doing RID-based storage. Graphite and stuff does it a lot better than just straight RID files with Whisper. But you still kind of have that idea that we're going to log things in really good detail, and over time we're going to downsample that. So if you look at data from a month ago, you're looking at 1 hour averages instead of the more granular data. When we were doing that, when we had RID graphs, we thought that was cool, we thought that was great. We really didn't bother us. But now that we can go back and look at details of 2 weeks ago, like this time period 2 weeks ago versus this time period now, and kind of see the differences at a pretty granular level, or we can do an upload test where we monitor everything in a data center at 1 second intervals and try to get really high resolution on everything and do a huge upload test. And then we can look at the upload test that we did a month ago and still see that same really 1 second resolution. And then when the test is over, we can switch it back to 15 seconds or 1 minute or whatever the normal interval is for that metric.
You can compare it to what you had like a month ago or a year ago and still drill down to the second.
So we found that very valuable to be able to compare those details at that time. So like LinkedIn, I have some people there that I've heard some of their stories. They have hundreds of thousands of RID files that they've built this great NFS-based system that shares these file systems, and they do polling everywhere, and it's crazy. Yeah. But so that's expensive. Like the more RD you're doing, the more disk operations it's got to do, and so then no longer are you just running your monitoring on systems. You've got to build out these massive SSD-based systems with 47 drives, and you're trying to make it scale brute force way. With those types of systems, we really couldn't change what our polling interval was. We had to pick a polling interval and kind of commit to it, or else we ended up with weirdness. If you tried to change that, and you lost your data. So now, we
tell us now how did OpenTSDB change the situation at Box?
So now we feel like it's a lot better. So we count pretty much everything. If there's anything to be counted, we count it. A lot of times we have no idea when we're ever going to go look at that counted thing is again. We have 34,000 metrics. We actually have a very low number of tag keys. It's only 45. I have no idea how that happened. And there's 108,000 tag values. So essentially, this would have been some multiplier of individual RID files, because the metrics and the tag keys kind of make up a distinct set of those kind of make up a metric. We're logging about 70,000 data points per second. We had a previous cluster that we were doing over 1 million, and it turned out to be that we had a couple of T collectors that were just spamming craziness. So we actually tested our system up to about 1.3 million data points a second, but as it turns out, that's the amount we actually need.
That's the thing. The idea is if you make it really cheap to collect and store a lot of data, then you can go crazy and just like every single number that's in all your systems, just collect them. Even if you're not sure what they mean, you just take them and stash them somewhere. And every once in a while, you'll find out when troubleshooting an issue that, oh, this weird counter that the kernel exposes, like about the sync cookies that it sends and it receives, and how many sync cookies are invalid, and maybe you've never heard about sync cookies before, but now you start caring. Well, you're happy that the data is there, and you can go and look at it and see how many sync cookies you've been sending over the past few months when you start realizing that you may have an issue related to sync cookies. So that's the idea. If you make it cheap to store data, you can just throw everything at it, and you don't care because it doesn't really cost you that much.
Yeah, so here's where I said we're talking about doing the tests. So for a test, we'll pull a data center out of rotation, try to blow it up, but we'll keep all the metrics at a really high resolution for that test. We'll drop everything down to a 1 second collection interval, and we'll get really good resolution on the numbers. And now we use, we just have a Nagios check that's queries TSD for, the aggregate of that metric for that data center or the whole system, which is something we really didn't have before. So now we can get alerted on this service is unavailable in this data center or globally, or a certain percentage of the requests, a higher ratio of failed requests is occurring globally, and we no longer have to have our on-call people be notified about 1 or 2 servers having an issue.
You would be happy with Sensu and the topic system that they have, where you could have topics per data center or something like that.
Yeah, there's a lot of interesting things in that graph that I thought we could use. So it's a push model rather than polling. So T-Collector runs on individual hosts. We have lots of scripts that whatever it sends on standard out, that's what T-Collector aggregates and sends to TSDB. So it's kind of keeps that same model as the previous system.
For those of you who don't know, tcollector is a small data collection framework that you can deploy on all your machines. It's kind of a shame because we have so many open source projects like Sensu and CollectD, and everyone is re-implementing like all the checks and all the data collection part of everything. So at least with Sensu, you can plug in your own backend, which is kind of nice.
Yeah, we have a lot of tools that send directly to TSDB and don't use the framework. We have a standard Scala service at Box that's an application built on a specific framework, and so that the Scala services themselves will collect metrics and report them back themselves. So they're self-reporting, so to speak.
Does that mean you have your service connect directly to TSDB to push the data to it?
Yeah.
Oh, that's fine.
Yeah, the engineers like it a lot. Sometimes I don't. So we have 20 TSD nodes in that particular cluster that's doing the live work. 10 would be easily sufficient. These are not crazy powerful servers. These are R410s. They've got, I think, 32 gigs of RAM and, a couple of disks. These are not expensive, fancy servers. These are pretty moderately low-end Dells. So, so we implemented a system now where we were trying to look at the logs that the applications would write and the engineers would put out there and try to glean bits of data out of them and generate our own metrics from their logs. That was really hard, and we don't have enough ops people to be looking at the logs and try to figure out what metrics are in them. So we made it very easy for the engineers to log a specific format as one of the log lines. Our system will watch all the logs and pick that up and send that to TSDB for them. So they really like that.
Do you think this is something you could have done with what you had before?
No.
Why not?
Well, we could have written a poller to connect to the server and tail the log and pick up the line and push it back through. It just would have been lots more polling. So.
Well,
So I guess we could
there's
have.
also like the issue of like what does it take to add more metrics to your system versus with TSDB you just start throwing more metrics at it and it just takes them.
Yeah, and in this case, whatever the developers define as a metric and a value, that's what gets stored, and they can immediately go look at it. They're pretty excited about that. The team that just did the first ones, they went and bought like 7 screens and set up their own little mini NUC, and they're really excited. So DevOps is alive and well at Box.
We're hiring.
Especially if you have
Who's
any,
not hiring?
especially if you have any age-based desire. So how much size is the data point in TSDB? Like how much can you store per TB?
So after compression and everything, it takes about 4 bytes of disk space currently, and I'm hoping to bring that down to maybe 1 to 2 bytes of disk space per data point.
Yeah, so you can store a lot of data in a very small footprint. So a single node cluster.
What precision is that?
The question is what precision is that?
Yeah.
TSDB does not, the goal of TSDB is to store the data that you give it. So if you give it a data point, it's going to try to store it accurately. Like you give it a timestamp and a value, and it's going to store exactly just that. It's not going to munge your data. It's not going to like transform it into something else. So there is no like question of precision. It's you just give it what you observe.
Float, double.
Oh, it's all on 8 bytes. So I mean, it's the variable length encoding. But if you want to go with like a long or a double, you can. Yeah.
Yeah. So it scales as easy as your H-based cluster does. We use Puppet and all kinds of other automagic tools. So DCOps plugs in a new server, and before they have time to close the ticket that says they got us a new server, it's already in the system collecting metrics.
To answer your question earlier about how much disk space you would need, I once computed that if you just do a default install of OpenTSDB and you don't add any extra collectors for your own stuff on 10,000 servers, it would take you about 4 terabytes of disk space per year to collect all the metrics, so the system metrics that come out of the box. So 4 terabytes when you have 10,000 servers, that's it's free.
Yeah. So this is the kind of the summary of how it changed our instrumentation or metrics world, as you would say. We use instrumentation where the previous guys would use the word metrics. So, but yeah, we used to pick out specific things. We used to go and specifically choose to measure something, define a metric for it, and all that. Now metrics come in from everywhere. Every team in the company generates their own metrics. They just appear, and we just keep the system up. And quote from the team: they did a new version this week, and it took them about 30 seconds from the time that they hit the release. So there was an auto upgrade process that happened. So as soon as they did the release, the sync clients upgraded, and within 30 seconds or so, the first sync clients that had auto upgraded were visible on their graphs. So they had basically a count of hard heartbeats by version is the graph, and so you started to see the old version dropping and the new version increasing just immediately.
I think this is one of the big things also that I really missed before I brought up OpenTSDB was to gain real-time insight into your monitoring systems. So you have a lot of systems out there that will collect data maybe once a minute or once every 5 minutes. And when you have issues in production, and you do something, you don't want to wait like a minute or 5 minutes before you can see the effect of what you've done. You want to see it pretty much immediately. So as John said earlier, because in OpenTSDB there is no like strict interval between the data points, you can go crazy. You can like collect data every second if you want to. Generally speaking, because data collection is so cheap, most things and people collect data every 10 to 15 seconds. I don't know what do you guys use as bugs typically as a data collection interval?
About half of them are 15 seconds and about half of them are 1 minute.
Okay, so that's great because like 15 seconds, for instance, is like you get a page, you go look at the dashboards, you see what's happening like right now, okay, maybe within 10 or 15 seconds of delay, and then you take an action, and if you have auto reload on the graph, then you see pretty much immediately what happened. And so this feedback loop and the time it takes is pretty important, I think, for people who run those large-scale systems.
So we went through this part of the presentation pretty quickly because we wanted to make some time for Gavin to show some of the tools we kind of built on top of the TSDB. But does anybody have any questions about this section of the presentation? Like 2 or 3 questions, maybe?
Yes?
How do you deal with disconnected network writes to the between like a T-collect and your central writer? Do you like batch stuff or?
Okay, yeah. So the question is, what happens when you? How do you deal with Node being isolated from the rest of the world temporarily, right? Okay. So that's one of the advantages of having a push model is you have those T-collector agents that run on the hosts and they collect the data locally and then they push it to TSDB. If they are disconnected from the rest of the world because of network split or something like that, they can buffer the data points in memory, and then when they get reconnected to TSDB, they can flush all the data. So that means that if you have like a temporary network outage, for instance, you still keep collecting data and you don't discard it. Of course, there is an upper bound on how much you will hold on to before you start using too much memory or something like that. But generally, it's big enough that you can, like if someone unplugs a cable in the data center for a small period of time, you can still get all the data while the node was essentially offline. And that's also pretty useful when you do troubleshooting because when you have a centralized polling system, as John was saying earlier, if you miss some collection intervals, either because you fall behind or because you have connectivity issues, then you lose data, right? The data that you didn't collect is gone. Whereas here, because it's a push model, it's whoever produces the data is responsible for pushing it to TSDB, and so you can get away with like network splits and such without losing any data. Do you guys have any other questions? Yes?
Yeah, we're looking at setting it up right now, and we've got a POC running, but I'm curious about what you said about small servers, cheap servers, but you've got them connected to storage rather than using local disk storage. Is that correct?
No, we're using local disk. It's a Hadoop cluster, so I mean, you don't put your Hadoop cluster on its hand. So each machine's got 4 disks in it.
Okay.
The first 2 drives are mirrored in the OS. The second 2 drives are 1 terabyte drives. So each machine's got 2 terabytes of available HDFS storage space.
Okay, perfect.
This is actually a pretty common question for those who get started with things like Hadoop and HBase. You really want to have just very cheap disks on the machines, and you JBOD them. You don't need like a disk array, RAID array. I mean, you don't need an AS. You don't need all that.
We generally put things in 1+0. We've got 4 disks on most of our systems, so that's great.
Right, and Hadoop will take care of the data replication such that if you lose a machine, you never lose any data.
Right.
So that's also the whole point of something like OpenTSDB is it's fully distributed. You can lose any node, and you don't lose data. You don't lose availability. Your monitoring system stays up because you can run multiple instances of it. And HBase is also a distributed data store, and it rests upon HDFS, which is a distributed file system. So the whole stack, from the ground up, is distributed and resilient to faults.
Perfect.
Is there anything
Yes.
notable with regards to like the HBase table structure or the way you guys deal with regions and things like that?
You generally don't have to worry too much about that because OpenTSDB just provides a higher level service on top of HBase, so you don't have to worry about like what is it like in the table and such. Of course, it's documented, so if you want to go and look at the bits that are in the table, you're more than welcome to. One common gotcha is people who get started with a new cluster that's like brand new and doesn't have any table in it, and you go and you create the tables for TSDB, and then if you want to start like pushing a ton of data to it, then you'll find that sometimes it's a little slow in the beginning because if you want to get really high write throughput from the beginning, you need to pre-split your table so that the table is already spread across all the nodes. But that's, generally those who get started, they get started at small scale, and then they keep adding data and adding data, and then the table will naturally spread across all the nodes.
Are you guys using like Cloudera 4 or anything?
There was a question that someone asked
We're
John
using
earlier.
Cloudera 3.3 on the current cluster, and then we'll do 4.1/4.2 on the next cluster in the next few weeks. We kind of decided how many regions we thought we wanted to have and pre-split. So we use a really high max file size, like 64 gigs or something, but we pre-split into 256 regions. So all the metrics are basically distributed pretty evenly across the nodes as they get written, based on their UID values.
Yeah, if you want to go at really large scale, it can be pretty daunting at the beginning if you're not familiar with HBase. There are definitely some tuning and some pre-splitting and configuring of max region sizes, as John says, but I guess most people, they just want to give it a shot and get started with like a simple node so that you don't necessarily even need a distributed setup. You can get started with like a single node, and you don't need to worry too much about that. I mean, it's when you start pushing more than 10,000 data points per second to TSDB that you start thinking a little bit about, okay, so how am I going to optimize my setup? And it's a good problem to have. And when you do have this problem, there are a lot of resources online to help you tune HBase. And there isn't much that's specific to OpenTSDB. It's just like general HBase tuning. All right, so I guess now we're going to take a look at some application that Gavin built. So Gavin is a operations/DBA guy also at Box.
Yeah, like Benoit said, I'm a DBA at Box, so I'm kind of on the edge of the whole like DevOps and metrics and monitoring but I have been building tools specifically to monitor our databases because I felt like what was out there already was kind of inadequate, and some of this stuff is kind of general purpose and applies to not just database servers, but is flexible enough to be used for other things. This is kind of something we're developing in-house right now, and we plan on making it open source. This is the nice thing. The reason I was able to do this is because OpenTSDB has a very simple interface for getting data back out of it. So it makes it pretty easy to put your own front end on top of it, or pull data out and process it, do your own analysis. And this is kind of getting something towards using it for alerting. Like you have the data in there, why not do something more complex? Right now we're using mostly Nagios for our alerting, and a lot of it's just threshold based, which doesn't always work across the board. You have different servers and different roles, and you end up kind of managing these thresholds and trying to put appropriate values. Well, I was trying to build something that would just use the data itself, the historical data itself, and basically tell you what's normal and what's not normal based on past data. So what this dashboard is displaying is these are actually server groups right here. So there's an aggregate, and the numbers there are standard deviations away from the normal. So it's going back. In this case, you can see at the bottom, it's going. It's taking 2 hours of data and it's comparing it to a week ago, for 2 hours, and it computes the standard deviation of the old data set, and then it's kind of comparing that to the 90th percentile. I think I have it. It's 90 or 95, and telling you how far away, how many standard deviations away the current data is from that past historical view, and then it's kind of sorting it by absolute value of standard deviation. So the most abnormal servers, or the most abnormal services in this case, kind of float to the top, and those are the things that you want to look into. And of course, on this interface, if you were to click on one of the numbers in one of those columns, it would take you to the graph, which is built from the data from OpenTSDB.
So hang on, can we just look again at the... So if I understand correctly what you explained, that means that this host group here, content, has 6 times more, 6 deviations more requests at the 99th percentile than for the past 2 hours compared to 1 week ago, right?
Right.
Okay, so you have your 99th percentile of the number of requests for this host group, and you know what the standard deviation of the 99th percentile is, and you're telling us that right now, those guys are getting 6 standard deviations more than a week ago.
Yes.
Okay, so you're essentially like resurfacing things that are deviating from the expected 99th percentile historically.
Yeah, yeah, that's exactly it. So it's just using the historical data, and the nice thing about this method is that it catches decreases in activity as much as it catches increases. So most thresholds usually set an upper bound, and it's not until it crosses it that you get an alert. But if your server goes dead and everything drops to zero, like you often don't get alerts on that. But that's kind of an error condition that you want to know about. So this is something that's able to capture
Or
that.
if your traffic takes a dip, for instance.
Exactly, you want to know about that just as much as increases.
So specific to that, it sounds kind of like a Holt Winters or some sort of seasonal algorithm kind of thing. Do you actively generate alerts on that metric right now?
Not yet,
Okay.
because it's pretty early in development. I've gotten in the habit of whenever I'm on call, I keep this up on another monitor
Exactly.
right next to me,
Yeah.
and I'm watching this, and I'm monitoring, our databases using this. So it's kind of, so I've been using it. It's been useful to me, and we're kind of, getting other people interested in using it at the company and putting more data into it and figuring out, which metrics we actually want to look at. I think John has been working on some of this as well, and I think he's done some like Holt Winter stuff. He's working on kind of that, integrating that kind of analysis as well. So, we're trying to make it flexible enough that you can plug in different analysis methods and stuff.
And I suppose the cool thing also about this is that even though you don't have alerting right now, because it resurfaces the things that are abnormal, you don't need to like constantly watch everything. You just need to look at like the top 5 or 10 worst things that deviate the most from the usual baseline. And this way you don't have to like look at tons of systems. You can just focus on like the most deviant ones, right?
Yeah, I mean,
Exactly.
as it's running, these things shuffle. So in this particular one, the CPU is a lot higher than it. You can see the spike. So you can see the spike here. So that's this row. Normally it would be buried down in the middle. Has the JavaScript is moved up to the top because it's got a high deviation. This one has got a large drop in the disk usage. And then basically you can see our system was running pretty well, so the third row down everything was pretty green. Everything's pretty normal. So
That's your app, not the open.
Yeah, it's the app they wrote on top of
Right.
TSDB.
the OpenTSDB interface is pretty basic. It does good things. It works for what it's for, but like if you put it in the hands of a person who's never used it, it's pretty scary. Like they're like we don't know what to do. You spend some time with it and you start learning what metrics your system has, and you can do a lot of good things with it. But we wanted to get something that was more accessible for everybody else in the company. So this will probably be open source at some point. It's not today.
Can you show us a live demo?
No, not really. I thought about it, but we just
Show us your site.
3 layers of VPN and batch hosts and stuff to get there. So
Yeah, we don't have any sample data to show you, so the only alternative is to actually go show the real live system data.
That's understandable.
So this slide had to be shown. Right? JC at Box.com are easy to remember.
How much is your hiring bonus? Problem is.
It's pretty high. That's why I recommended my email address, not John.
So everybody has to mail John, not Gavin, or anybody else on Plus.
I wrote the presentation, so.
That's right, actually, you deserve all the credit. So OpenTSDB is obviously open source. We also encourage you to go on GitHub and fork it. Check out the site on OpenTSDB.net. I actually put up something recently that's not fully finished yet, but if you want to try it without installing it, you can go to try.opentsdb.net. GitHub has this really cool thing, try.github.com. They have like this interactive system where you can almost learn Git and GitHub from your browser. So I'm not quite there yet, but what I did is I just set up OpenTSDB on a typical node and put it up there, and you can go and poke at it and play with it.
Can you send the metrics?
No, you cannot write to it right now. It's read-only, but it's monitoring itself. It's like it's a machine that's monitoring itself, and so you can go check it out, and you can like make some requests to it and see what it feels like. Yeah, that's it.
All right. So is there any additional questions?
Well, how do you feel about the state of the UIs in OpenTSDB? Because I think, and even alerting on top of it, it seems to me like it hasn't gotten that adoption yet. Facebook kind of made it something, but.
Yeah, so as John said, there is a UI that comes with OpenTSDB. That's what you'll get if you go to try.opentsdb.net, and you'll see what John meant by it's not very inviting, I suppose. because I'm like one of the worst UI guys on the planet, and I had to write something, so I did the best that I could. I guess I'm like the Sensu guys, where they had somebody step up and help rewrite a better UI. So maybe you can lend me to this guy.
The monitoring scripts for it are pretty good though. We do use a lot of we do pull a lot of data out of it to monitor. So we have Nagios alerts set on what's the TSDB's last 5 minutes average say.
But to answer your question, TSDB right now is just a monitoring system. So it does one thing and it does it well. It's storing and serving massive amounts of time series data for very cheap. So it doesn't really answer any of the needs that you have on the alerting side. So you would have to plug it into something else like Sensu or Nagios if you still want to use Nagios after having seen the Sensu presentation. I don't really know why anyone would still want to use Nagios anyway, but it's pretty popular still out there, has a large install base. So there is a script that you can use that ships with OpenTSDB to use TSDB as a Nagios plugin. I guess you guys maybe wrote your own. You said you were doing alerting from TSDB data. Did you use the?
We're using CheckTSD.
Oh, okay, you're using
standard Nagios
CheckTSD.
plugin.
Okay, so it's just a Nagios plugin that you can use to alert based on the data that's in TSDB. As far as dashboards go, I'm really hoping for initiatives like what those guys are doing, which is they build this awesome dashboard and they're going to release it. So I know of several other companies that built their own dashboard, and I think one of the big focus for the next release of OpenTSDB is going to be to have better APIs so that people can build their own dashboards more easily. Now, having said that, if one of you guys would like to step up and help build a built-in dashboard system to OpenTSDB, that would be also really cool.
Do you have a question?
I have a question about non-numerical data. Are there any plans to store like non-kind of metric data, like say you want to join with a ticket or an event or some sort of text, like still in a time series sort of format, but you want to say pop up a deployment and then link to the deployment or something in your graph?
Like an annotation?
Yeah.
Yeah, annotations. So funnily enough, I started a thread on the mailing list yesterday because this is also a frequently requested feature. So you want to have the ability to like add a mark on the graph, and you want to put like a label at this point where you say some code was deployed or we know it said some outage started or some networking event started. So there is nothing right now to support this, but there are two different implementations on GitHub to provide support for annotations. And this is also something that I'm hoping to integrate upstream in the next release so that you'll have the ability to annotate your graphs at arbitrary points.
Yeah, just a follow-up to that, something that we do internally to account for that. One of our release engineers, so that we know when code deployment happens, just set up a metric that constantly increments until code deploys, and then drops to 0 on deployment.
Yeah, so
And
we have
just-
a metric for minutes since last change, and so it monitors deployments, Puppet changes, several different types of changes in the environment. Yeah, so if you put one of those metrics on there, you get this nice line that goes up and drops, so you kind of get the vertical bar.
Or man's annotation.
Yeah, it works okay.
I'm looking forward to giving you something better than that.
We knew you were, so that's why we didn't make it better.
All right, do you guys have any other questions? Yes?
Yeah, if you want to look at, it's great that you store the original data that was given, it doesn't get interpolated or modified like RD tool. But if I want to look back and look at the last week's worth of data, that's a lot of data points. Or if I want to look back, or someone in management wants to look back for the last 6 months, that's too much data. You aggregate it in some way? Is that built into OpenTSDB, or is it easy to add on?
It's not built in, but we can pull a couple of months worth of data on a particular metric. It's not super fast, like it takes 25, 30 seconds, but it will pull it.
Can you give us an idea of how many data points that involves?
Well, it's one data point for every 15 seconds over whatever window you're looking at for most of our metrics. So some of our metrics are 1 minute, so the value would be less, but it's still a lot of data points.
But I suppose there are like a lot of hosts involved, so you also multiply it by the number of
so
hosts
it's
and everything.
so there's 2,000 hosts, and yeah, it gets multiplied based on your tag keys and values. But it does it all server. It doesn't send all those points to the client, try to render or anything. So you can do downsampling, and so NewPlot runs server side, generates the graph, and sends the data. So it works pretty well. But yeah, we have an out-of-band process that will read metrics out of OpenTSDB and then write back in a downsampled metric alongside the original metric. We don't talk about it. We don't use it a lot. It's not that useful. It's kind of kludgy. We're waiting for his refactoring of the read streams to kind of do that for us in a future version. So I don't know when he's going to do that, but it's coming, right?
Yeah, it's coming. You're making a good point that if you store very granular data and like data that's coming in every 10 or 15 seconds forever, and if you want to look at a year worth of data, then you have very fine-grained data for like thousands of hosts, so that's going to be like tens of millions of data points. And my goal for TSDB was to be able to read about 1 million data points per second on a read query. Now there are a lot of different characteristics to your query that could make it slower or faster than this, and it also depends on things like how big your cluster is. But even if you could read 1 million data points per second, it's still going to be too slow for really large time spans, right? So the question really is, how can we get pre-aggregated data in the database, right? And so there's nothing right now that will do pre-aggregation for you. That's why those guys had to build a system to like read the data back, aggregate it, and then write it somewhere else in a pre-aggregated form. Now it's such a common need that I'm hoping we can have something where you can tune for a certain specific time series and say, like, for those time series, I want pre-aggregated data for like 5 minutes interval, hourly intervals, daily intervals, and then it would still preserve the original data, because it's one of the tenets of OpenTSDB is to always preserve the original data forever and make it really cheap to keep all your data forever. But it's also going to store elsewhere pre-aggregated information to speed up those queries where when you look at like 1 year or 2 years, you don't really care about what's happening down to the second at this time. So it's not there yet. It's coming. There are a lot of features that people want on the roadmap. I don't know how far down this one is, but it's definitely something that's often requested and that I think will happen.
One more question.
Yes?
Is using CollectD as a collector just looked down upon? I just figure it's so mature, it's got so many plugins, everyone kind of understands it, that using that as your OpenTSDB collector would make kind of sense.
Yeah, so about CollectD, it's actually unfortunate because when we started writing tcollector, none of us I was at StumbleUpon then, none of us knew about CollectD. I'm sure that if we knew that there was this effort already ongoing at CollectD, we would have used that. There are at least 2 or 3 things on GitHub that I'm aware of that will bridge the gap between CollectD and OpenTSDB. You don't have to use tcollector, like you guys
We use a
push.
couple of things.
Yeah, well, you use it, but you also push data directly to TSDB. We saw earlier also that you can use Sensu and then push your data out of Sensu into TSDB. So by all means, you don't have to use tcollector. It's just one thing that's conveniently out there that will natively integrate with TSDB. Now, yeah, it's if you want to use CollectD, that's also fine.
Pushing data to TSDB is just open up a TCP connection, send a string, and you're done. So, yeah. Pretty much anything you talk about.
You can do it in one line on a shell script. But... All right.